U današnjem vlogu govorimo o tehnologiji laserskog kuvanja. Kako ja nisam specijalista za ovu tehnologiju laserskog kuvanja, meni će se pridružiti niko drugi do čovek koji je patentirao ovu tehnologiju. U pitanju je Jonathan Blutinger, koji je na doktorskim studijama Kolumbija Univerziteta i danas uživo i direktno iz Creative Maschines Laboratorije sa mnom Jonathan. Hello, Jonathan, and thank you for joining us in this Addicted to Food vlog. It's my really honor to meet you and to speak about this really interesting topic. But before we continue with this topic of laser technology, I would just like, before we start, that you introduce yourself and also to mention something about Creative Maschines Laboratory from Kolumbija University.
Sure. Well, first off, thanks for having me. My name is Jonathan Blutinger. I'm a Ph.D. candidate at Kolumbia Engineering. I'm in my fourth year of my program, and I'm in the Creative Maschines Lab. So a lot of the things we work on in our lab are we basically work on robots that perform tasks. What I mean by that is a robot or a machine that can print food or prepare meals for you, or another robot that can combine ingredients and different materials into one, multi-material structure, or robots that have sentience and that can think for themselves and be self-aware. So in a way, we create machines that basically give legs to AI. So we can create these interesting looking models and then apply interesting, give them some smart brains by coding them in a certain way and have them do interesting things. So we do a lot of interesting things, and one of them is printing food.
Yeah, that's really perfect, because in one of the previous vlogs, I have been talking with Emilio Sepulveda from the Natural Machines, and we talked about 3D printed food. We talked about Foodini and the new Foodini that has this technology of laser cooking. And actually, I didn't want to go in deep with Emilio with this topic. I really wanted to talk with you because you are actually someone who is really doing on this, and I have read lots of articles that have been written by you and your colleagues about this topic. And because we are in the food industry and in the food safety business, this is the new technology, and I would really like to present to the audience this technology in manner of the food safety. But first of all, for me, very interesting is the question: how did you come up with the idea of making the laser cooking technology?
So I guess it starts with food printing, which started in our lab in 2007. If you look back at kind of when 3D printing first started, it probably started in the 80s, but it didn't really start with food until 2007, which is Hod Lipson, my current advisor, and the advisor from the lab. He was working on it with a student, and they created an open source 3D printer, and which was the first of its kind, and they basically kind of let people play around with it. And they noticed that most people actually, when they print with things, materials that they find off the shelf, most of them play with food, because it's something that we all have to eat. It's something we all make in our homes. Yeah. So when you think about it, like a machine that's designed to make things, then, people will naturally kind of move towards food, which is really interesting. So they kind of played around with it, but back then it was still kind of like a frivolous activity. They'd use dough and peanut butter to test the machine because it's cheap and it's easy to get a hold of, those materials. But when you start to add data into the process and you start to think about how you can customize nutrition and do a lot more in terms of customization, sort of realize that you can actually create more nutritious meals and, better things for the actual user. So then the issue becomes, how do you cook it? Because you have a machine that can deposit ingredients at a very precise level, but you don't have a cooking method that can really complement it. You have ovens, you have stovetops, you have microwaves, but they work on the same principle of heating like an entire area by some uniform amount. So that's when our professor was like, okay, let's look at lasers. Like lasers are used in industrial manufacturing for welding and for other things. So maybe it doesn't have the best connotation necessarily, but you get targeted heating, and you can control the heat on a very, very small level. So that's kind of where I came in a couple of years ago, and we started doing laser cooking. Before that, there was only one other paper we found, which was some Japanese researchers who would laser cook some bacon. But before that, there was a pretty uncharted area. So we just kind of took it up and we're like, okay, let's try to cook dough. Let's try to cook other things. Let's try different lasers and let's see what happens.
Yeah. Well, actually, you mentioned bacon. The bacon, you can eat it even the raw if it's dry and smoked and
Sure.
etc. So, but interesting from the publications that I have read is that you actually used some ingredients like dough, like you mentioned, but also I think among the last of the publications there were like Atlantic salmon that you used. So it's interesting because it's a raw meat type of meat. So can you just share some results of this cooking with us? And also, what is interesting, I mentioned also when Emilio said we can 3D print something also with meat. For me, interesting because in Balkan, everyone is about meat and eating this meat.
A lot of carnivores.
What about cooking or using this laser technology on a raw meat?
Yeah. So like you mentioned, we started with dough because again, it was the easiest thing to get our hands on and kind of the lowest barrier to entry. So we tried it with a certain type of laser, a CO2 laser, which is an infrared laser, a mid-infrared laser. And the wavelength of the laser, it actually does make a little bit of a difference on the actual cooking. That's one of the main findings we found. So for this laser in particular, an infrared laser does a really good job at just cooking the surface. It can kind of brown the surface. You can get different levels of browning based on how you change the speed, the power of the laser, and a couple other factors. And then we started to hit dough with a blue laser, which is a different wavelength. And we realized that blue lasers actually penetrate a lot deeper than infrared lasers. The reason being is different wavelengths. I don't want to get too sciencey because I know your audience is probably more food-based, but I'm not a food guy, which is also worth noting. I'm an engineer, so I'm taking this from another perspective. But so like basically, in layman's terms, a blue laser can penetrate much, much deeper into a food because the water content of food is so high. And this laser, the heat from the laser has a very easy time passing through water. So basically what that means is a blue laser can penetrate deeper, an infrared laser can just brown the surface. So if you kind of see where I'm going with this, if you can combine both lasers or multiple lasers, you can get different types of cooking. And when I say penetrate deeply, I only mean, a couple millimeters, maybe a quarter of an inch, which doesn't sound like a lot. But if you think about a food printer, you're printing only about a couple millimeters at a time because you have this 3D printer head, it's printing food. And then if you cook it, you print, cook, you can kind of layer a structure that's being cooked throughout as it's being printed. And you can do a lot of interesting things with that. And then briefly, you mentioned salmon. Salmon was one of the first meat products we kind of wanted to test with because we figured, like you said, you can eat certain products that are raw, but you can't, maybe salmon you can also eat raw in certain cultures, but it's higher risk, I guess. So we wanted to go with a higher risk product like salmon. We may have another paper coming out soon on chicken. but we're trying to explore some interesting new foods like, you know, chicken, beef, salmon, other vegetables.
Yeah,
and as we're going through them,
totally.
yeah, as we're going through them, we're basically finding that we can do it. We can cook it very well, and it actually comes up with some different results than normal cooking too, which may actually be better.
Yeah. Well, as you mentioned, there are two types of laser used. I also read about on your website and also on Creative Machine website, and I understood a little bit because I'm also an engineer in basics, but dealing with the food safety. But actually, what is interesting, you mentioned that with these lasers, you actually bring the, let's say, a really high amount of heat on a single point on this, let's say, food product. And that would mean what actually is can we measure maybe the degree of this, let's say, temperature that is given in the point of where the laser is influencing?
Yes, and yes, in fact, we can. We did some tests, again, in this paper that's not published yet, so I don't want to speak too much about it, but
okay.
I can give you an idea of how we did it. But basically, if you have an infrared camera, a camera that basically measures heat signatures, okay. What we did is we cooked food, and we had a laser above it as it was cooking it. We took a video of it, so we could see real time what's going on in the food. And basically what it looks like is you have, you know, we'd follow a little pattern that would go around the outside and then kind of work its way inward for the laser on this little piece of chicken. And it would look basically like a pulsed heating. Like you'd see this pulse of energy that just kind of follows wherever the laser goes. And then as the laser passes over and it goes away, it kind of drops down again. So in an oven, you can kind of, or like in another heating source, you can probably imagine the heat signature of the food. It would slowly rise all at the same rate, and you'd see the heat kind of build uniformly. But with a laser, you get this pulse heating effect, like you mentioned, where it basically just pulses. It gets above a certain temperature. So in doing a lot of these tests for chicken or for salmon, what we're looking for is we want to get this pulsed heat above the minimum temperature threshold, which I think for salmon is 63 degrees or 64. And then for chicken, it's like 73, 70 degrees, depending. Yes. So what we do is we try to find these markers we have to hit. And then we would basically just run the tests or optimize the cooking pattern so that it reached the point where it would just go above this level. So we could say it's officially cooked. And then we would actually try to eat it.
Yeah, well,
but there's no better way to test it, right?
Yes, of course, and you would find out the results in, let's say, 4 or 8 hours if it's good.
Exactly. We're still here, so
yeah. So I see it is working. Okay, so as I understood, in the 3D printed technology, you have like layers that are printed, and this is practically very clear. And then each layer would be cooked with this laser technology. And in reality, that would mean that your food product would be, let's say, evenly cooked in every specific area, which is not the case when you roast it on the pan. Sometimes, you will have in a pan, for example, the heat transfer that you transfer it on the surface of the product. But inside the products, sometimes you don't get the same degree of the temperature.
True, yeah.
And in this layering technique, practically, you can influence with the laser on every layer. So let's say that it could be even safer to do it like that. You can have some even cooking, which is of course great. And this is why. I asked you, how did you actually test the food safety of the product? And you mentioned we tried. So I think that this is the best thing. You try the product, yeah.
Yeah, I mean that's part of it, right? But there's also a lot more to be done. And like I mentioned, we're an engineering lab first and foremost. So there's only so many tools we have to actually test the food safety of it. So perhaps you'd be able to actually give better advice on that. But we were trying to work with we were trying to partner with someone from another food safety program, another student. Unfortunately, due to everything that's gone on in the world in the past couple months, it's been hard to coordinate that. So that's kind of on hold right now. But that is something I've wanted to pursue, is actually to look at the nutritional value of laser cooked food versus, say, oven cooked or traditionally cooked food. The only other tests we did, besides organoleptic evaluation, actually trying it, would be for the dough structure. And kind of early on, we looked at micro kind of images of the micro scale of what's going on the nutritional level, like of the starch gelatinization of dough. And we did notice that dough that's cooked with a blue laser and dough that's cooked with an oven show very, very similar starch gelatinization, which from my understanding is an indication of how consumable a dough product is based on the baking process. So that was promising, but again, that's only one piece of the story. You need to have kind of the full thing. You need to have more nutritional studies and that sort of thing. But I think at a very kind of early stage, based on the resources we have, we're showing some good promise.
Yeah, that's really nice. And one of the, let's say, the most important things in the food safety is to evaluate any possible hazards that could be influenced by technology that is used in the preparation of the food. In this case, we are using two types of lasers that are with different structures and influencing differently on the product. And from your experience, that is now the biggest one, can you just say, are there any possible hazards that could influence the food, like some type of chemical hazards that arise from the use of this technique, or any radioactive or radiological hazards that can come up from this technique?
To my understanding, I don't think there would be any radiographic or radiologic issues that would arise from it. Like normal cooking, we've noticed with lasers that you can get burning, which is probably the most similar thing. But other than that, it's hard for me to answer that too much, because again, we haven't done many tests on a micro scale. But those are questions I'd want to know too. Based on smell, based on taste and that sort of thing, we're not noticing anything too super out of the ordinary. And those are kind of the two main things we rely on for our senses when we're trying foods and when we're eating new things. So that's promising. But yeah, there's still a lot to be explored. So I guess we'll just have to stay tuned.
Yeah, of course. Well, of course, I will follow and check on the data. So because this is really interesting topic, and in the future, I think we will talk more and more about this. For now, we can see the use in the 3D printed techniques. So actually, as a kitchen appliance like Foudinis, we can find it, let's say, in next years, maybe in our homes, and even look at this laser cooking technology. But what about using of this technology maybe further in the food industry?
Yeah, so like originally this kind of grew out of a need to want to cook things more accurately on a food printer. But as we're creating more stir around this idea and talking with more people, we're noticing other applications of it. One of them being an interesting add-on, since it is such a small form factor, like having a laser, with maybe a couple mirrors to direct the laser, we can kind of fit that. It's kind of an augment to other cooking appliances. It can be used, say, in a microwave, for example, because microwaves are great at cooking foods from the inside out, and they're kind of usually when you warm something up in a microwave, the middle is really hot, but the outside's not, because it excites the atoms. So we saw this as a great add-on maybe for a microwave, but I think right now the price point's still a little bit high for them. So I think with time that will change, because, as lasers become more popular, like even in the past 10, 20 years, we've seen the prices of lasers drop, especially for blue lasers, which is a very common one we use, just because of the Blu-ray disc industry, right? So, who knew that blue lasers would be such high demand, but technologies like this, for creating entertainment and media has totally transformed that industry. So things like this will change, I think, with time. But for right now, that was one interesting application of it. Another one, which is still kind of in its infancy for us testing, is being able to cook foods within their original packaging. So with the laser, it has a certain wavelength that allows it to permeate plastic without melting it, without doing anything harmful. So you can actually cook ingredients within their package and potentially grill them, which could do really interesting things for certain food manufacturers when they think about their SKUs and, you know, meals ready to eat on the go. So they could keep their ingredients raw and potentially cook them on the fly, which is really interesting to think about. But yeah, I mean, those are just a couple, you know, they could be integrated into other manufacturing pipelines, say for making burgers those frozen burgers you get in your store. A lot of times those grill marks, people don't know this, but a lot of times those grill marks are chemically added to make it look like grill marks. But so what if you had a laser that actually grilled it up for you, or customized it for you, and it had your face or your initials on every burger, so you know it was made for you. So I don't know. There's a lot of cool, interesting things, but right now we're just trying to push the technology forward as long as we can.
Yes, of course. I think this is absolutely new technology, absolutely interesting for the food industry. You know, as I think about the food industry, this is something that, as you see in this crisis, this is something that people are, you know, letting everything else go and only focusing on food, trying to find the food and only this main raw ingredients and preparation at home. And also what I talked to one of the previous videos was these trends of the industry that asks from us to have some new specific types of food, new proteins introduced, but also these new technologies and the products that are more, let's say, made for me, you know, like the personalized products, we can say it like that. And of course, what is interesting, you mentioned in all sorts of industries it can be used, but when we come back again to the laser cooking or just the cooking time, what is the time of the cooking with the laser?
So right now the time is not its value add, I'll say. It takes some time. Granted, that will change with the higher the laser you use, the size of the food you're actually cooking. So what's interesting is that it actually scales with the power and all these other things. So it's hard to say, you know, if you have this size of chicken, it'll take this amount of time. But right now, the time, I'd say, is not the benefit. I think when people think about this technology, and food printing for that matter, so laser cooking and food printing, usually they think of incremental change. So they think of making things faster or cheaper or better. But when you think about this technology, I feel like we always need to remind people that it's not about an incremental change. It's about thinking about a whole new way of thinking. So it's like comparing the rotary phone to like an iPhone, for example, right? Like it's hard to make that comparison, I think. So so in that way, you know, right now it takes a little bit of time. You know, if you want to cook a little piece of chicken, you know, it might take a couple minutes, you know, if it's a little square, but like I mentioned, it's about kind of a new way of thinking and a new way of combining ingredients, and it'll just totally change the way you cook. So yeah, it's especially now, like you kind of alluded to, like people, when everything is going digital, especially restaurants, and they're trying to do deliveries, it almost feels like the right time to be working on this, because I think it's just a matter of time before, you know, even after this whole pandemic is over, I don't think things will go back to the way they were, and not in a bad way, but like kind of in an interesting way. You'll see kind of new innovations which are already starting to happen. So I think one of them might be this whole digital cooking move, which might hopefully find its day.
Yeah. I like the name, digital cooking move. Yeah, that's nice. And you mentioned, but even if the time is not, let's say, same or something that is not added value, what would be added value is actually, and you already mentioned that, is the nutritional value of the prepared food. As I understood, the nutrition value is conceived in the food. There are no losses and you could have a really nutritious meal prepared in this way. And because you already mentioned you tried this food, laser cooked food, and can you share what is the taste? Is it
Yeah,
good?
so it's hard for the creator to test the actual food because I will be biased. So we tried getting a couple of non-biased people to try the food, and we did a blind taste test. You know, we had some laser cooked food and some other cooked food. And I think the biggest takeaway I noticed from doing these tests is that the moisture level is actually higher in
Okay.
laser cooked food than it is in other cooked food, because I think you're not reaching those really, really high temperatures. So it's not drying out the food as much. Other than that, they noticed, you know, for chicken, for example, and there's this, we kind of pour more into this in our paper, which hopefully coming out soon. We talk more about like even like the fibrous nature of chicken. When you usually bite into it, you feel the fibers. Even in 3D printed food and laser cooked chicken that's been printed, you still have those kind of fibers that you can kind of reminds you of normal cooked chicken. So yeah, we're noticing a lot of parallels. But again, I think the biggest thing is the moisture change and the fact that the food doesn't shrink as much when you laser cook it. Again, I think because there's less moisture loss.
Perfect. For the industry, this is perfect because you don't have losses then in the way of producing your actually product. So yeah, that's really interesting. I would really like to try this laser cooking and this food, and to go more deeply in the food safety. As I see from my side regarding the food safety, I don't see any hazards that could be influenced by this laser. But also I see the temperature could be right, that that all the raw ingredients could be cooked evenly, and this is something for the food safety at, let's say, this start, that is great. And just for the end, I just want to thank you again for connecting and for sharing your experiences about this.
Of course, thank you so much, Vladimir.